So, anyway, today, Sunday, the 5th of April, and I'm on my own at the moment, but might find a friend later on, and I'm at Wellington Point. Now that's much further down the bay than I was yesterday. I just took my glasses off, and that can't be a cruise ship in the distance, surely not. Anyway, you won't be able to see it, but I can. I suspect it is. Anyway, we're down here at Wellington Point, way down the bay, and if you have a look across the bay here, let's sort of pan around, then you'll see that we are sitting on a shore that's sheltered by North Stradbroke Island. There's still a reasonable amount of fetch in front of us, you might just be able to pick out Dunwich. And the wind today is definitely, I'd say it's got a lot of east in it, maybe a tad southeast as well. So, I wonder what we'll find here. Not sure, but quite highly impacted by human activity. I'm standing on a boat ramp. There is a rock wall going out next to it, a jetty that's been put in, and despite the COVID-19 disaster, it's absolutely jam-packed. Absolutely jam-packed. Anyway, let's go and have a look at some of the critters that might be here. So I mentioned the other day about Lyngbia, I think it was at Manly. And here again is Lyngbia, and lots of it. On other beaches we saw the council actually sort of moved it away, but here it's just sludging up against this disused boat ramp. Some looks a bit bright green, so could be doing quite well. Might take a little sample of that to trundle back home, see if we can find some Metis holothuriae. So anyway, lots of nutrients being brought ashore here. The sediment. Yeah, well, the sediment, see what you think. So, the sediment. Anyway, we've got something moving here. I'll have a look at the sediment in a second. Got my glasses on here, it's so bright. What have we got moving here? What on earth is that? Do you recall from yesterday? Actually, it's what I was calling Polynices. The Moreton Bay guide calls it Quandamooka. Same thing, it's an antacid snail. Cruises along just under the substrate, hunting for bivalves. So, shall I disturb it? No, but you can see the track. They're easy to pick. Just looking for the moving end, that's all. Also, just as I stood up, guess what? Our old friend the Serious having a hunt around, this time out of water. So, bold and brave, baby hermit crab again. So looking a bit like the Nudgy Beach system. Alright, so to the sediment. We're in, there's water sort of flooding out of the beach there, probably soaks into that area where the rock wall is. Runs out as the tide drops, and now this area is fairly saturated, it's fairly squidgy. I'll show you that, it's kind of plastic almost. And that's dilatancy. It's sucking, great stuff. When you press it down, you drive the water out of it. Sorry, I'm showing you. See it will wobble? And when you pull your foot up, it sticks. You get it out. There you go. Imprint. But not just sort of squidging entirely out like at Manly. Sorry, like at Manly. Alright, so the sediment then. What's our prediction? Lots of nutrients. Not a lot of sign of bioturbation. There's a few holes around the place. Not bioturbation. Fairly small sediment size, I think. If you look at it. Yeah. Some slightest movement of water basically lifts it up. Like Hillstrom diagram energy in. Let's dig down and see what's happening here. Oh baby, there's a worm just popped out. And look at that redox layer, very, very distinct. Very distinct. There's maybe 2 to 3 millimeters of oxygenated material in below that redox. So you've got to have a tube. If you want to look down there, you've got to be a reducing bacterium. Pop it back nice and gently. Getting the pattern. We've got a new player. This one's a polychaete worm. Or Phyllodoseverens, it's just sneaking in a little bit there. Phyllodoseverens. Active predator if we can find something. You can see the mucus sort of drifting off its body. They produce lots and lots of mucus. So, obviously Virens, they get a little bit larger than that. You see it hunting around. So, oh, there's a bit of phytobation going on there. A little bit there. They're hunting around, and if you find something, they like carrion particularly, so if you find some dead animal somewhere, then Phyllodocy will flood towards it. That's all hermit crabs. Hermit crab, hermit crab, hermit crab. This again, this shore is alive with hermit crabs. You can just see there, everything that's moving around is a hermit crab basically. Remarkable hermit crabs everywhere, every little space on this soft sediment is covered with hermit crabs. Hermit crab central here, look at it. Crazy. Anyway, so we should do a project. Looking at another Phyllodocy, this one a little more brightly coloured than the previous. Why are they green? Why would you be green? Why would you be bright green and stand out like that on a shore like this? Why aren't they brown? Why aren't they hiding? Anyway, they do when the tide comes in, they all pop down. They've got this sort of endogenous tidal rhythm, and they actually predict the tide coming in, and they dive in the sediment. It doesn't matter whether you put them in a jar and take them out up the shore and sit there and watch them. Even though they don't have the stimulus of the tide itself, they will still predict the tides for about 3 days and bury when the tide is coming in, and then come out and forage when the tide is out. So also, reminder of these things. Remember the wobbly thing that Tamara found yesterday? Pretty sure it's snail eggs. Similar sort of thing to the Quandamooka that we saw. So a mucus mass, very viscous mucus, and then the little larvae, or sort of the embryos inside that. Probably. There's lots of Phyllodocy, the green paddleworm coming out now. So it's a fight between Phyllodocy and the hermit crabs, basically. Alright, there's a fish doing something silly here. What's going on? Right in the very shallow water. I don't know what it is. Where are you? Let me see you. No, you've gone. Alright. Oh, there it goes. Oh dear. Too fast. Anyway, picking up from the story the other day about the crab action, look at the rocks here. In terms of their colour and the sort of sheet nature of it, it sort of screams lava, doesn't it? I'm pretty sure there's a basalt shield of some kind. So the basalt, very runny lava, has run out over this area, and I won't say shore because it may have been millions of years ago, probably was millions of years ago. Now it's exposed, and it's got those pock marks that we saw up at Redcliffe, remember those? And as we go close, you might be able to see the crabs scattering. So again, lots and lots of nooks and crannies. Crabs love this stuff. Yeah, and they're all out grazing on the surface as I sight them from some metres away. And as soon as we get closer, they duck for cover. There's one just running there, one there, everywhere. So it's the same structures, probably the same volcanic sequence as that which was at Redcliffe. And here, it's doing the same trick. It's providing habitat for a lot of crabs, and those crabs are doing a lot of grazing because you cannot see much algae on the surface here. Well, actually, I'm telling a lie. If you look up there, the rocks are red. Down here, they're black. There's all sorts of microalgae living in the surface of the rocks there, right in the very surface, and that's what the crabs are picking off. So, remarkable. Didn't really make that connection before. Kind of useful doing this in short sequence, you know, a few days. And here we go, they're covered in, oh, there's the crabs going again. And then down here, a bit lower down the shore, and then rocks now are discoloured, sort of brown, sort of sediment deposition here. There's actually a grazing snail, look at that. Isn't that wonderful? I've got to use the pointer, otherwise I don't know what I'm looking at. Hang on, I haven't got my glasses on. So that's actually I don't know, it's Morula. That's another, that's a predatory whelp, mulberry whelp. Amazing. Then here is a grazing snail. Where are you? There you are. And that one is you know, it's the one with the thing, Ostracochlea porcata, that's right. It's a grazer. There's an oyster. Oh, actually, no, it's a pearl oyster. That's pink tartar. That structure's here, just there. That's pink tartar. It's a pearl oyster. And then here's another. What's that? Morula attacking at something else. Another snail. One of the cerithids. It's great. Wonderful structural habitat. Very, very good. So low tide today. Was it yesterday? 106. Today it's 2 o'clock. So that's that lunar progression I was mentioning. Tide's driven mainly by the moon. Interesting. Going for another crab trick. Another crab trick. Let's see if I can balance this dang headband thing. I'll give you some shore to look at. There's see the edge of the water, I think, just a bit. Alright, see you later. Meters, 1 metre, there he is. How'd that go? So another thing, just where I was before, all the hermit crabs, all the little snails, phyllodes running around. The seagulls standing there, there's free food. Why aren't they going for it? I think this lot like chips. Anyway, there's a greater egret over there, away distance. I don't have a zoom on this thing. Anyway, greater egret hunting for prey. Into time. Alright, so again we're up on top of this platform of lava, alright, basalt, and these air bubbles that have exploded and provide all these spaces. There's a Metabographis running around, and we're higher on the shore now. You see the colours sort of are red, more reddish than it was lower down, and there's algae, but we've got a lot of snails here, and there's a Ostracochlea just mooching around, probably having a feed inside that little puddle, and then next to it clusterwings, Planaxis sulcatus. So, and every little nook and cranny has a snail in it. So up here, maybe the snails are pulling their weight in terms of grazing, but lower down it seemed to be dominated by crab activity, particularly Metabographis. Alright, let's right into it. So here's a seagrass bed, different sort of one than we saw yesterday. Quite long seagrass. And we've got 2 species here. And if you see, one has oval shaped leaves and the other has long thin leaves. Right? Now I brought a magnifying glass down with me today to try and discriminate between them, and I think the long thin one is Halagula uninervis. I can only see 3 longitudinal veins, the long thin one. The little round one looks like Halophila decipiens. It's got little serrations at the end of the leaf. I think I need a microscope really rather than magnifying glass, but anyway, mixed bed, 2 species of seagrass in one area. We're right down towards low tide level here. Low tide's in half an hour. and so we're quite far down the shore. Again, this is moving to a spring sequence. The full moon's on the 8th, and more hermit crabs. It's got to be a hermit crab story here. Anyway, short shot. Here's Vadina again. So you remember that from a couple of shores. Egg mass is Vadina. So Vadina likes a hard substrate, so it's got to be something higher than there. Again, look at the wave action here. And a lot. That's the principal direction of the wind right up there. Well, here we have, I think, Haddon sea anemone. It's a carpet anemone. And there it is, carpet anemone. Lots of tentacles over the surface, central mouth, often inhabited by a shrimp. It's a cleaner shrimp, whose name of the genus is Thor, Thor, which is pretty impressive. This one isn't. It's a juvenile, and this would be a cleaning station for fishes that live in the intertidal. And here it sits among some Halophila ovalis. And I'm panning out somewhere for some reason, and then back to the Haddons and anemones sitting in this nice seagrass bed. And what else have we got? A bit of biotubation, some lingbia scattered around, attached to the seagrass here rather than washed up on the shore. That's where the dang lingbia gets. And over here we've got Iotrocha. It's a black toxic sponge. If you rub it, you get red on it. That's a neurotoxin. You get red on your fingers if you start playing with that. Yeah, there you go. Play around with it. And yeah, a little bit of red. Yeah, neurotoxin. Don't lick your fingers. Wash your hands all the time. Nice one. Halophila ovalis, Ostracopricorni, seagrass, small lingbia. Right, so, unusually, remember we're in Moreton Bay, right? We're not in the tropics. But this stuff here is Alameda. Coming, honey, like Padina, it has a calcium carbonate core, and it's more so commonly associated with reef systems. So Alameda cylindrica? No, not cylindrica. I forget it anyway. Alameda, but a reef, involved in reef formation. Alameda, very important. Nothing eats it. Horrible stuff. Anna's just found something else. I'll try it. I've got most of my glasses. Where's the baby? Oh, it's so cute! Oh, it's a baby! It's a baby! It's a baby shovel nose. Look at that. Can you see it?
You can actually submerge it, Dad, and then they get a clear shot.
You reckon? I'm going to get my camera in the water. Oh. There you go. I tried. It went. Very cute. Oh, where's he going now? Oh yeah, there he is. Have another go. Little shovel nose ray. So, cartilaginous fish, of course. Let's see it, yeah. Alright, it's there. Triangular head, eyes, spiracles behind the eyes. Two dorsal fins, nice caudal. Most locomotion combination of the tail and those two dorsal fins, and also the pectoral fin you see flapping around, changing direction. So, rather nice. But, yeah. Beautiful animal. Beautiful. So Hannah's sort of nailing it. Yeah, can you point it out with a stick, please? I don't want to lose my fingers. Fortunus armatus. It's a sand crab. Pretty aggressive. Can you flip it over so we can see the sex? Is that alright? Crab, do you mind me looking at your rear end? Is that alright? Good. Oh no, actually, wow. Underneath, this is a male on top, because below it is protecting a female. Let it go. Let it go, let it go, let it go. It's breeding.
He's letting go.
Yeah, let go, let go.
Can't.
So underneath is a female. So when crabs molt, actually it's no, when the female reaches the terminal molt, she's then ready for insemination by the male, and the male protects her, and she's soft shell and she's underneath him until she hardens up again, and then she can run off and carry the eggs. Hannah's just trying to get rid of that. Sorry. Come on, crab, let go please. Come on. Please just let go. There we go. Alright, we'll leave you to your happiness, man. Great. Be good. I'll leave you alone. You're doing an important job. Just a reference point where we are. Oyster catchers out there, a few little brown wading birds. There's the shoreline. We're at about 250 metres, about. And we come across the first coral, which is just here. There we are. It's hard coral, where are you? There you go. Hard coral. And it's a favorite, I think. Pretty solid. And that one is one of the honeycomb corals. Very sediment tolerant of most of the genera. So, Ceritid nearby. Here's Sargassum, young form of Sargassum. And next to it is Cystostera trinotis. We saw that the other day. Both brown algae. There's some Halimeda. This is getting really algae-ish. This is getting really good. We'll carry on. It's a really wonderful show. You can't walk more than a few centimetres without bumping into something. Here's something I don't know well. I know it's Callurpa of some kind, but it's a weird shape. Really strange. I'll look it up. But yeah, this is all like algae plus. And this Callurpa has runners going along the sediment, so we're doing that binding trick we talked about. So another puddle. There's a fish. Oh, there's a pufferfish. Toadfish. Hello. Bye bye. Yeah. Lovely. Seagrass, algae, all that connected habitat there. All these mangroves at the top of the shore, that's all. Then you got the whole kit and caboodle. Oh, something's going on. Someone's been digging this out, right? Coarse material. Bit of cracking in the back here. So is it a crab? One wonders. I'm not going to stick my hand in, I'm like Brewer. But yeah, something's been digging the seagrass up here. Digging the seagrass means shoveling out sediment from underneath the seagrass. I don't know, I can't talk about it. I don't know what's going on. Swans. And another one, another excavation of some kind. Stingray maybe? Oh, I don't know. It's a puzzle. So Hannah's just about to stand out of the sunlight.
No.
And then there's a lovely soft coral. All the polyps are attracted. Next to that Hydrocata, that black toxic slimy sponge, or black toxic sponge, the one that makes the red. But yeah, soft coral. This is going to look, heron reef flat in about 50 years. It's going to look like this. So anyway, if we get Moreton Bay back in shape, it'll look like Heron Island reef flat. And here's another soft coral. This time with the polyps out. So it has little polyps, just like a regular coral, and it catches plankton from the water using stinging cells. So some hairy muscles just next to it. It's only hard substrate will have something on it. Another soft coral. So yeah, that looks like, look, branching coral. Dolph, you might be excited with that. I guess branching corals just don't. There's another bit covered in algae. So they don't float around, they don't drift in with the tide. These things grew here. So once upon a time, this was not a flat dominated by things such as the favids. This was an area dominated by acroporids, right? Branching corals, the bringers of complex habitat, super diversity, reef type stuff. So yeah, another acropora, didn't float in with the tide, it grew here. Nice. So now we're actually subtidal. We're wading in amongst the Sargassum, just looking around for stuff. Come back to you when we've got something, soft coral, sponge, fish. Oh, it's lovely. See how far we can go. Oh, I see a crab. See the cheliped there in the distance? Just sneak him out. Is it alive? Is it alive? Well, doesn't look very happy. I don't know if you're alive or not. Oh, it's a peeler. So actually, this crab, I was talking about that the other day when I looked at the crab fragments. So it's actually brightly coloured. It's very fresh. Maybe it's that female. And then crab, to get larger, has to crawl out the back of its shell. So it splits there, leaves the gills behind. Oh man, bloody GoPro. So it hops out, leaves the gills behind, leaves the eyes behind, and yeah, it's a female. Broad abdominal shield for carrying eggs. So yeah, lovely jubbly. Maybe that's the story. Glory. Yeah, and Hannah's just found next to a mussel clump there. This is pinna, or razor clam. On the outside of it's growing an oyster, several oysters, and some hairy mussels, Trichoma hirsuta, and it's sitting next to soft coral. This one's alive, it's in life orientation, sticking up like that, and if we were to wiggle it out, you'd see the full shape, but I'm not going to do that. These things have enough tough times in their lives. Alright, so pinna, razor clam. So alright, a couple of algae here again. There's a little shrimp there swimming around. There's that calopa again, the one I don't know, which I'll hunt when I get back. And then here, and I'm in the sun now, is the Halimeda. Is it Halimeda discoides or something? Or this one here, these green plates. Anna's urging me to put the damn thing in the water, so I will. Red mud lobsters, sometimes they call them. Attacks, yes. Really dense sargassum and cystosera. And you can see them. Those vesicles coming into play with both species, raising the plant up off the seabed with great brown algae. Lovely habitat for a whole range of things we can see scurrying away as we walk through this. It's just wonderful stuff. A bit of an underwater view since I'm dowsing the dam. Point of clarification. Cystosera trinotus, which is this, doesn't have tubeless vesicles. They're more cylindrical vesicles. They're basically spindle-shaped vesicles. Trinotus, three of them. Three nodes. Another one.
Probably Quandamooka. Quandamooka is a hard pole. It's unusual to collect that in the day. That's Quandamooka, he can't really tell you.
That's Quandamooka, day coral, in Moreton Bay, at Wellington Point.
Another species of soft coral. Polyps floating around.
Sometimes I just popped a tube worm back in its hole accidentally as I walked past and wanted it to see the tube worm come back out, and of course I've stirred everything up, and because all these algae are here, they're slowing the water velocity even though it's very windy, so it's just not clearing, not working for me. Gotta go, heels triple forever. We were wandering over the shore and we saw this white thing. And we were going, what's that white thing? And then as we walked out towards it, we find it's a ghost pot, and that's very annoying because ghost pots keep on catching long after they've been laid, and animal crawl in there, won't be able to get out, dies, another animal crawls in. I think it's a pretty safe one because it's full of algae and stuff. Hannah's going to lift it up. Anything in there? Flip it over. Is there anything in there? Oh.
Sorry.
That's right, no, just leave it in the mud, that's fine. Wow, nothing in there. But we're obliged to remove it. We're obliged to remove it. So we can find out who owns it. That's where it gets me in legal trouble. It's supposed to have the name of the owner on it. And, oh, instead, there's some beautiful algae. Yeah. Where are we? We've got to take it out. How do I turn this thing off? 55% battery. Alright, so we dragged the crab pot up just instead of having a look at it. It's got the markings on it, owner's markings, but sadly, Ken, someone called Ken. Anyway, Ken, here it is. And then underneath it, we've got lots of interesting things. This is, I think it's a sponge algae sort of combination. I've seen it before. But anyway, it feels like a sponge, and obviously it's bright green. but it's been laying down, so it seems to be doing fairly well underneath there. Here's sargassum hanging onto it. That's the rope actually. And there's also oysters. Is it Tesseropora? I forget. Balanoids anyway, some kind. Yeah, interesting what you find down there. But we're going to have to reclaim this. I don't know what to do. I'm in a dilemma now, I'm in a quandary. Because it's got lots of living things on which I don't want to remove from the bay. So there's a little crab, a sponge. No, I'll let you do it. What is that? Obsidian. There's a little pink tartar, that's a pearl oyster. Where?
If there is.
Oh, it's a pearl oyster. Alright, okay, fair enough. Alright, stand back there, hand over crack. Go on, be cool. Vicious, be savage.
Be savage.
Oh, there's a big crab ran out of it. What was that? Oh, hello. Metapagrapsis again, our old mate. Down here? What are you thinking? Yeah, it's mainly those was that Obsidian? I'm sure that's Obsidian. Remember those barnacles we saw yesterday on the mangroves and how they grew vertically so they can compete with each other. These guys are doing that. Oh look, polychaete worms Hannah's found. Look at the little muscle, they're a beautiful place. Here's a polychaete. Let's have a look. There's a bit of it anyway, which ends up. It's the wrong end. It's on the head. It's on the head. Hello. Anyway, polychaete worm. An annelid. Under half of it scurrying away with its partner. Come on, Hannah. Whoa, crab. What's in here? Is that sponge algal combination? Benefits of both worlds, I think. Alright. Can you get that pink tartar off? Just pop it down. It's a baby pearl oyster. Just pop that back in here. Wait in there. That one. That's alright. Okay, we're done. That's enough. I think we've got a bunch of. See, I think what's happened here. Oh no, the person's only put a half float on, for goodness sake. What is that about? Yeah, whatever. Craziness. Some more obsidians. Okay, Han.
Yeah.
Let's go, kiddo. Alright, so just reference. So remember yesterday I was shooting south towards the port of Brisbane. So the Brisbane River's over there. You can see the cranes in the distance of the port itself. Little yacht. And there's Green Island, St Helena behind it. Then a Robin, which some people call King Island, joined by a big sand spit. There's other people walking around there. So another very big shore, similar sort of shape to yesterday, but different sediment again, and lots of intertidal seagrass. I mean, there's acres of it, acres and acres of it. Wonderful stuff. Anyway, we're going to trundle up the spit, I think, and have a look at that sandy spit and get a bit of downtime in. Downtime, like downtime, but downtime. Dan Harris, that is. Alright. Ciao. Yeah, alright. We've moved on to another area of shores of mussel plant. Basically in coral skeletons, mussels attaching to the outside, doing their filtering stuff. There's, what else have we got here? I saw some Halimeda floating around. There's the Halimeda. Stood up in the sun, sorry about the glare. Halimeda. And then here, possibly near an octopus's laid, expect to see fresher shells, whole pile of shells here. Something's been eating them and dumping them here, so maybe there's an octopus about. Have a look. Testing, there's a toadfish coming this way. The tide's just starting to make, it's gone after 2 o'clock. And if you see, what's happening is that the fine particles that have dried out on the surface of the exposed sandbank are being lifted off by the incoming tide. It's always a signal that the tide's on the rise. I used to see it on the estuary back home where I grew up, and you always knew when the tide turned. The silt started lifting off the mud bank. There's a little furrow here, so I'm going to be digging a hole. So, what do you reckon, big crab, Halimeda? Come on. Clear, Damien. there you go. That's a thalameter. It's one of the swing crabs. It's not a edible one. This one is a savage little beast. Oh, there he goes. I think it's Thalameter crenata. Yeah. Thalameter, what's the other genus? Anyway, have a hunt. Oh man, Charybdis. It's not, I don't think it's Charybdis, I think it's Thalameter. Oh, well, no, I put it on. Stabilisation as well. So Hannah just forced me to stop here. There's a coral rubble zone, obviously like thousands of years old, or thousands of years. I don't know. Look at Matt's paper on that with John. Anyway, in terms of habitat complexity and habitat patches, you can see this shore is very patchy. Pools, some places you've got dead corals with sargassum. Here's a whole field of it, things squirting and jumping. There's an amazing amount of life here. Seagrass patches, then you've got bare patches over there in the distance near where that windsurfer is. There's a sandbar kind of made up. So these are really mosaic habitats. Here's a bank stabilised by seagrass. And see how it's much higher than the surrounding area. So when seagrass gets in, it'll smother all this other stuff. And as we walk through the seagrass, you can feel the coral underneath. So this is what would have been a coral flat, a reef flat that's been reclaimed. It's been claimed by a lot of sediments. Those sediments are then stabilised by seagrass. It's quite a very rich ground. And in terms of connectivity of habitats, it's very clear here about what those are. The only thing we're lacking is mangroves at the top of the shore. Instead we have a sandbar. This has got to be stingray. These got to be stingray pits. Nothing else would do that, I don't think. Sand crab maybe, but I can't see put in the effort. Not myself. So more puddly pours. Here's another interesting one. Better get me shovels and my glasses on. Just there, you'll see like a straw sticking out, smack level with the water. That's Chaetopterus peripentus, and it's I don't know. Is there a common name for it? Anyway, Chaetopterus. Yeah, it's a tube worm. It's a parchment tube worm. That's right. So below that straw-like thing, it widens out into quite a thick tube, and then in there sits a worm that filter feeds using a mucus sac and specialised parapodia. So no doubt someone will flash up an image of that at some stage. There should be another one somewhere, the other end of the U, but I can't see the other end of the U. Maybe someone's trodden on it. Anyway, parchment tube worm, egg case. Lots of hermit crabs running around. Someone do a project on that. Alophila, something or other. Yeah, beautiful place. Now, everyone knows what that is? No? Which way was the stingray facing? Oh, I gave it away. You can see the two piles with the wings, just absolutely plain as day, right? We're going to see another one. No. Same thing. Just gorgeous. Alright, stingray feeding pits. They're all over here. And some of these have water in them. This might be holding little fishy. No, this is absolutely perfect. It's like a dream run. So here we've got a stingray feeding pit, smaller than the other ones. I'll put this in just so you know. Can you see the little fish in there? I'm not sure what they are. I'm not certain they're whiting. They could be whiting. They're certainly not gobies. And I'll just move around a little bit so they move. Look at them all. So remember the story about the pools, stingray feeding pools? Habitat engineers, and they're providing a home for these little fish, avoiding predation. Marvellous. Well done, fish. They're only a week or so out of the plankton, I suppose. Right. So, let's see the stingray feeding pits. Water velocity story here. The ripples from yesterday. Ripples again today. A bit obliterated by the soldier crabs. There's a soldier crab area. You can't see them, but they're there. We can tell by the little pits that are here. That's classic soldier crab. And basically what soldier crabs do is they're turning over the sediment. They exclude things like the seagrasses. So if there's lots of soldier crab grazing activity turning over that sediment by activation, then what you're going to lose is seagrass. but the seagrass can get its own back. Soldier crabs can't burrow into seagrass, so it's kind of like a little Mexican standoff between the two. These guys are going to keep working the sediment, and the seagrass will get kept away. These holes here are different. These are Tripea, which is Callinacid mud shrimp, like lobsters, they're big ones. And Callinacea makes a quite complex long burrow, drags water in, and you can see some of the effects of bioturbation there with the grayer coloured, dark coloured sediment. Again, I focus most on primary producers being algae and seagrasses, but again, diatoms all over the place here. So, another conundrum. What is going on? Anyway, just small fragments of red stuff. That's small fragments of that basalt, I think. Something weird. Something weird here. It's found another caulerpa. This one's Cuprozoides, I think. It's like a cypress tree. I think that's what's called. See it on the Heron Reef Flat as well. Oh, is it? It's definitely caulerpa. It's a green alga. Alright, so if you can see them, there's lots of pyrazis around here. You can see the tracks they're making, those mud whelps. We're getting close to the bar now. We're getting quite a way away from the ocean. We've walked quite a way up the beach. And here, there are pyrazis tracks everywhere as they crawl around licking the sediment, picking up all that nice detritus and diatoms. So, another thing about pyrazis is they've been referred to as a trophic dead end. This in a food web, if stuff gets in, pyrazis eats food, nothing eats pyrazis, boom, end of story, right? So it's not contributing to anything above. But it's doing a bit of bioturbation, bless it, so forgive, I think. Much more stingray action here, I love it. Shooting for a different little clam. These are small stingrays, and I think they're after little clams. We'll see if we can find a payfees. Payfees is a little bivalve. Anyway, sorry about that. So, where are we? We're right near the sandbank. Talk about that in a minute. For now, I'll just kick the sand away a little bit. And there's payfees, little bivalve. You get them on heron as well. Mid upper shore, quite an remarkable bivalve. Can't spend more than a few hours a day feeding. And it's just, put the bucket in, if you can see the discoloration on it. With heron you can tell which end's been feeding. This is discoloured, this has been up. I think that's the end there. Alright, so that's what those little stingrays will be chasing. And then heron they chase some other things. So payfees, bivalve. Lovely job. So back over it, make sure it's heavy. Now we're on this bank, this spit that goes out to King Island or Roban. I'm going to swing around slowly and then go back and show you the main base at Wellington Point. And coarse grained sand again. I could do the water test, but you know it by now. See that? Coarse grained sand. So higher wave energy than any of the rest of this stuff. Alright, you can see all that saturated sand, all the damp sand down there, and this stuff dries out, the water drops out of it very quickly. Lots of sorting, so well sorted, fairly coarse grain compared to the rest of the material, and this spit linking the mainland over there with King Island or Roban over there. You can see that the back edge of it, which is the eastern edge, the eastern edge is fairly gently sloping. It's very steeply sloping away here, so I think this is probably, Dan can talk about it, but maybe prograding to my left, but I don't know, because it's been here for some years. I've never seen it broken, so anyway. But the seagrass is starting to get inundated, so we better go see if we can find some creatures in the muddy seagrass area. So Hannah's just pointed out the human footprints here. We assume they're humans. And look at the amount of impact on this little bit of shore, right? People everywhere. And this is now the... There's a bit of dark latency in it. Lingvia again, Lingvia is everywhere. I better get a sample as well. So lots of human interaction here with the marine environment. Poor old marine environment. Shouldn't let people ask questions anyway. So we're just musing, Hannah and I, about these poor old crabs. So the shore's littered with them. They're paraphthalmids. They've got long eye stalks. They feed on the sediment. They've been muddier sediment. So I've probably got some shots of those from earlier, from near the jetty, the slipway. But the quandary is, or the question Hannah asked was, because the crabs get disturbed by so much by humans wandering past, are these going to learn to come out more quickly, or are they going to be more desperate? So maybe have a think about how you'd set up an experiment to test that. What conditions would you need to test the response times of macrophthalmic crabs and disturbance by humans? Yeah, there's crabs all over the shore here, moving around slowly, feeding on the sediment, eye stalks high, looking for predators. Humans potentially are that. Alright, so again, raised area, coarser sediment, fiddler crab zone, just like we saw at the shore yesterday, so remarkable stuff, you know. So again, a very patchy environment, we mentioned earlier. And here's just crab heaven. They're starting to pop out of the holes, Hannah and I standing still, and these crabs get really, look at the footprints around them. These guys really get hammered. So they've got this trade-off between avoiding predators, finding enough food, you can see the little balls lying around, and controlling their territory and mating. So quite a tough gig for these things. Wellington Point, and there's all the cars. Very, very busy Sunday. This is where you want a telephoto lens on this damn thing, but you won't be able to see it. But believe me, these crabs are being marvellous. They stand up on their back legs and they wave their claws in the air, which is a territorial display. It's absolutely beautiful. I don't think the macrophthalmids doing that. I think they are. So they stand on their back legs, or stand tall on their legs, and then wave sort of like a, what do you call it? Like a, if you were to describe a yawn with your arms, it's like that. They're as high as they can be. It's like a cat puffing itself up. Anyway, we'll have a look. Maybe we can zoom in and see some of this stuff. But even the ones close to us are doing a bit more of that now. As Hannah stays very still. Lovely. We're looking for mud skippers, actually, not we all. Yeah, baby. Listriolobus. Oh yeah, it's Listriolobus, wasn't it? Yeah. Like, yeah, it's tongue worm. So spoon worm. Alright, so Listriolobus here, and it's a deposit feeder. And I hope they don't disturb the dang thing. But there's Listriolobus. Its tongue's out, so it's a spoon worm. Alright, so Moreton Bay Guide has its own subclass or something or other. To my knowledge, it's a polychaete worm. So the body of the worm is a big bulbous pink thing down deep in the sediment, probably locked amongst coral branches. And then this tongue extends out over the surface, and there are cilia on the surface of it and mucus, and those ciliary tracts move detrital particles back to the mouth of the spoon worm, and so it feeds. Often you can see them because you find a hole, or you see this tongue thing lying out maybe like a radius of almost like a goose's foot or something like that, because that tongue's been moved around by the worm. Here it's got a rich source of mucus, it's just hoeing it down. If I were to touch it, which I will, you'll see it disappear down the hole. And then we'll ask a question. I think. Hi. There you go. There he goes. Back to safety. So, of course, that worm has got a sensitive bit of its anatomy on the substrate, which it uses to feed, so it's a very important part of its anatomy. So how does it assess risk when some big clown like me comes up and touches it? Interesting question. How long before you put your hand back in the tiger's cage? Yeah. There's several others around here as well, I can see. Oh no, that's good. There's a little crab feeding there. There's little chelipods going to his mouth. But if you can see it, the stalk eyes are sticking up. See if we can do a zoom in somehow. But the stalk eyes are sticking up there. He's feeding away. See little clouds of sediment as he picks up bits of detritus. Little, I don't can I call it? Macrophthalmus. And they live in burrows again, so they'll run off and hide in burrows. Alright, so that's us. Back to the car park. And Hannah's dragged that net all the way up the shore because it's a ghost net, and so we're going to get rid of it now. And then there's lovely Wellington Point. Don't show any faces. Out to a robe in Port Brisbane. And that cruise ship, which I'm sure is a cruise ship, still profiled over there. Alright, good luck, Vienna. Okay, so this is getting annoying now. So we've got the strand zone, top of the shore. Beach is very steep, alright, so the energy would, any wave energy, that would be a bloody westerly, norwesterly, wouldn't it, coming from that direction, strike against here. So again, higher energy, well sorted sand, no redox, but we've got some erosion signals to worrying. Here's a transition zone between the marine environment and the land, and of course that's much different to a beach up at Noosa, for example, or Mooloolaba, where you've got a very extensive beach and dune system before you get to actually the terrestrial transition. But we've got the strand line bearing some stuff, but we're losing stuff. We're losing shore. You can see here that there's some old tarmac when there was a car park area. They've since grassed over. Look at that. So yeah, quite remarkable. These bags, which were put there to try and reinforce the shore, are now washed out, and the lifeguard has gone. That's the lifeguard station. No lifeguard. Right. So anyway, yeah, so we're losing shore. Maybe there's some accretion over there, I don't know, but disclosure. The signs up, Moreton Bay water's closed to shellfish collection. Don't be shellfish, don't take shellfish. No, don't be selfish, don't take shellfish. Can you see that? Oh my word. Hopeless for the sun, isn't it? Anyway. Alright.